In this video, I will go over velocity and speed. So, what is velocity? Velocity is displacement or change in position divided by the time of travel. So, average velocity is equal to del x over del t. V bar is the average velocity, this is change in position, and this is the time interval. From velocity's definition, can you deduce whether velocity is a vector or a scalar? Velocity, as we can see here, is displacement over time, and we know that displacement is a vector. So that means velocity is also a vector. If velocity is a vector, it must have both magnitude and direction. So when we are talking about an object's velocity, we must indicate both how fast it is moving and in which direction. For example, if an airplane moves -10 meters in 5 seconds, then what is the average velocity? The average velocity is change in position over time. So -10 meters divided by 5 seconds, or -2 meters per second. So this is the magnitude and this shows the direction. But average velocity only tells us what happens to an object on average over a span of time. From average velocity, we don't know what happens to an object between the starting point and the ending point. To have that information, we need to consider the movement of the plane over a smaller and smaller and smaller and smaller time interval. If this time interval is infinitesimally small, the average velocity becomes the instantaneous velocity. So, instantaneous velocity is average velocity at a specific instant in time. And just like displacement and distance, we must make sure to not confuse velocity with speed. Speed is a scalar, which means it only has a magnitude and it does not have a direction. And just like velocity, we have both instantaneous speed and average speed. What is instantaneous speed? Instantaneous speed is just the magnitude of instantaneous velocity. So if instantaneous velocity is, for example, +5 meters per second, or if it is -5 meters per second, in both situations, instant speed would be just 5 meters per second. We only need the magnitude. Now, here's a tricky part. You might think average speed must also be the magnitude of average velocity, but this is not the case. To calculate average speed, we must divide the distance rather than displacement by the time of travel. So, average speed is equal to distance, rather distance traveled, divided by time. So let's say I am running from point A to point B. and this is 5 meters. So I go from A to B, and then I come back from B to A. What is my distance traveled? Distance traveled is equal to 5 plus 5, or 10 meters. But what is the displacement? Displacement is 0 because I came back to where I started. So my average velocity would be change in position divided by time. So 0 divided by time. So my average velocity would be 0. But average speed would be the distance traveled, or 10 meters, divided by, let's say, 5 seconds, for example. So that would be 2 meters per second. So as you can see, the average speed is very different than average velocity. Okay, so this is the end of part 2, and in part 3, I will go over acceleration.